We've been talking about exponential functions. Now let's talk about the other half of this discussion here, the logarithmic functions. So the logarithm function with base a, y is equal to log sub a, base a of x, is defined so that a to the y is equal to x. So the thing to realize here is that there's these are inverse to the exponential functions. So if I say, looking here, a to the y is equal to x, well, our exponential functions are like y is equal to a to the x. Now we're interchanging the roles of x and y here. So these two functions are going to be inverses of each other. Of course, we have a special logarithm function, just like we have a very special exponential function. The natural logarithm function, g of x, is log base e of x, where e was that number from a couple of videos ago, 2.718, ... And there's a special way that we write this ln of x, natural logarithm of x here. So e was 2.718, ... as before, with all of the properties that we discussed in that video. So just as e to the x will be our most important, exponential function, the natural log of x will be our most important logarithm function. Let's do a couple of very brief computational examples here. Log base 3 of 81 is equal to what here? We want, if this is y, we're trying to figure out, so the base here is 3. 3 to the y is equal to x, 81. What number 3 raised to the what power gives us 81? We should realize that is 3 raised to the 4th here. So the log base 3 of 81 is equal to 4. The natural logarithm of e to the 5th is, well, once again, let's write this down. That this is e raised to the what power, y, that's what we're trying to determine here, is equal to e to the 5th. And I think we can see pretty easily that this needs to be 5 here. Okay, let's talk about some more properties of logarithm function. I'm going to do this for the natural logarithm. Natural log of 1, so that would be e raised to the what power gives us 1. E raised to the 0th power, e raised to the 0th power gives us 1. So the natural log of 1 is 0. And also, the natural log of x is an increasing function as x gets bigger and bigger and bigger. As x gets bigger and bigger and bigger, then the natural log of x also gets bigger and bigger and bigger. Let me now draw a picture of what things look like. And I should also, I think there's one more note I need to make here, which is the log of x. All natural logarithms are only defined for strictly positive values of x. So let me draw here what our natural logarithm function looks like. So we know that log of 1 is equal to 0. Log of 1 is equal to 0. It's an increasing function. It looks like this, and then it actually, as x gets closer and closer to 0 from the left here, this keeps getting closer and closer to the y-axis, but keeps going down. It goes down to negative, You can make this as negative as you want to. It's going down to negative infinity. We'll be able to make that more precise in chapter 2. And there's actually a nice picture connection between this and the exponential function. So this is y is equal to the natural log of x. If we take the graph of the natural logarithm function and reflect it over the line, this is y is equal to x, then you actually get y is equal to e to the x. So the graphs here just mirror limb over the line y is equal to x. Okay, so this is the introduction to logarithms. Let me just, we'll definitely do a lot more examples of them. Let me just offer a brief historical note here that we present exponential functions first and then say, how do we go from exponential function to logarithms? Historically, if you take a look in math history, logarithms actually come first. So logarithms were developed in the early 1600s before people were thinking as carefully about exponential functions. And logarithms were they no longer are used for this as much anymore. But in pre-computer days, if people wanted to do lots of computations, long hand computations, it was often easier to facilitate them facilitate calculations with logarithms, because instead of multiplying numbers together, you could add their logarithms together. We'll see in next video that multiplication kind of becomes addition when you deal with logarithms. And so many scientific discoveries starting in the early 1600s and going on for hundreds of years were facilitated by people doing hand calculations with tables of logarithms. So there used to be these books that would just have pages and pages and pages of logarithms written out to lots of decimal places to facilitate computations.